This lesson is over how to solve inequalities. Let's look at our number routine. A checking account balance is not more than $500 is written as this. C is greater or equal to 15. Is that written correctly? Let's think about it. The checking account cannot or no more cannot be more than $500. If it cannot be more than $500, here's $500. Wait, here's $500. Cannot be any higher than this. So therefore, everything has to be less than that. So I don't think this is written correctly. It should have been the checking account has to be less than or equal to 500. It should have been written as this inequality. So let's look at our number root or do now. Traveling salespeople for a book company are paid at least $250 for each trip they take to sell books. Write and graph an inequality to describe the amount salespeople are paid per trip. Let's do some examples, see if it makes sense. If they are paid at least $250, can they be paid $300? Yes, they can. Can they be paid $400? The least they can be is $250. Yes, they can. What about can they be paid $200? I don't think so. It's the at least. I mean, 250 is the least they can be paid. So that means it could be include 250 and all of these amounts. So that means let's use the P for paid. It has to be greater than 250. It can even be equal to 250. So traveling salespeople can be paid greater or equal to $250 each day, or at least $250 per day. So again, in inequalities, we have the less than symbol. If you do get confused by this, think about is this. This is how sadly, this is how I memorize it. To make the inequality symbol less than, you have one dot here, two dot, connect the dot. So this side is less than that side. So greater than, this is the greater than symbol. It can also be more than. This is the less than or equal to. It could be also at most. And last but not least, this is the greater than symbol or equal to. It can also be worded with the word at least. So in solving an inequality, our aim is to have the x, or whatever the variable is, on its own on the left of the inequality sign. Something like this. X is less than 5. Y is greater or equal to 11. We call that solved. Solving inequality is very like solving equations. We just did 4, 5, 6 days of solving equations. So go back to past lessons if you need help. So we do most of the same thing, but we must also pay attention to the direction of the inequality. Direction is which way the arrow points. There are things we can do while affecting the direction of inequality. When you add or subtract a number from both sides, when you multiply or divide both sides by a positive number and simplify a side, the inequality sign like this stays the same. So, for example, this is almost like an equation. Let's solve this like an equation first, and then we'll see how similar it is to an inequality. What I need to isolate the variable h. What is the inverse operation of minus negative 3? It is plus negative 3. So plus negative 3. This cancel. H is equal. What's 15 plus negative 3? They're more positive than negative by 12. So H equals 12. Do you notice how in this example it is almost the exact same thing? The only different in equation has an equal sign, while inequality will have an inequality sign. So same thing, but here is H is greater than equal to 12. But you always have to check your work. Just like in an equation, you need to check your work. So Can you think of a number that is greater or equal to 12? For example, like 13. So we plug it back in, substitute back in, 13 minus negative 3. You add the opposite, so it's 16. Is 16 greater than 15? It is true. So I know I did it correctly. So let's graph this. Let's graph our equation. H is greater than equal to 15. So it's, wait, yeah, I'm sorry, H is greater than equal to 12. Actually, this should have, this is a mistake right here. This is a mistake. This should be 12, and this should be 12. So let me go erase this. So it has to be least to greatest. I like putting that down. So H is greater than 12, so it has to be down here, and it equal to. All right, so let's practice on some stuff. Before we learn how to solve equations, let's look at some examples of discovery lesson. A plus 2 has to be greater than 0. If I plug in, I substitute a negative 5 up there plus 2. What is negative 5 plus 2? Negative 3. Is that bigger than 0? I don't think so. False. So we know negative 5 cannot be part of it. Negative 4 plus 2. Negative 4 plus 2. That's negative 2. Is that greater than 0? False. So let's scratch this out. We know that's not possible. Negative 3 plus 2 is negative 1. Is that greater than 0? False. So we know this cannot be possible. Negative 2 plus 2 is 0. Is 0 greater than 0? False. So we know that cannot be true. All right, let's do negative 1 plus 2 is 1. Is 1 bigger than 0? That's true. I circled this. 0 plus 2 is 2. Is that greater than 0? True. I circled this. What about 1 plus 2 is 3? Is that bigger than 0? That's true. Circle that. What about 2 plus 2 is 4? Is that bigger than 0? Yes. I circle this. What about 3 plus 2? Is that bigger than 0? Yes, it is. What about 4 plus 2? That's 6. Is that bigger than 0? Yes, it is. Circle it. And what about 5 plus 2 is 7? So, as you can tell, it's all of these make it right in this inequality from negative 1 all the way to past 5. Now let's learn how to solve this inequality. So let's solve this algebraically. A plus 2 is greater than 0. So we need to isolate the variable a. How do you isolate it? You do the inverse operation. That's minus 2. Minus 2. This cancel. A is greater. You know, I've always seen kids put an equal sign. They're so used to the equation, they always put an equal sign. Nope, use the inequality. What's 0 minus 2? You have 0 minus 2. That's negative 2. So A has to be greater than negative 2. Let's go back to our graph. Let's actually graph this. Are all these numbers greater than negative 2? Hey, it does work. So it has to be greater than negative 2. So can it be include negative 2? No. So we have to circle greater, least to greatest. So we have to shade it all the way to the greatest side. So it's all these. Let's try another discovery one. 5 times m has to be less than or equal to 10. 5 times negative 5, that's negative 25. Is that less than or equal to 10? Definitely true. So I circled this. 5 times negative 4 is negative 20. That's definitely less than 10. True. 5 times negative 3 is negative 15. That's less than or equal to 10. Circle it. 5 times negative 2 is negative 10. That's less than 10. Circle it. 5 times negative 1 is negative 5. That's less than 10. Circle it. 5 times 0 is 0. Is that less than 10? Yes. Circle it. 5 times 1 is 5. Is that less than 10? Yeah. Circle it. 5 times 2 is 10. Is that less than or equal to 10? Yes. Circle it. 5 times 3 is 15. Is that less than 10? No. Cross this out. 5 times 4 is 20. That's less than 10. Cross it out. False. 5 times 5 is 25. Nope. Cross this out. So it changed right here when you reached the 2. So anything less than 2, it worked. But anything 3 or more, so we need to solve this algebraically so we can see where exactly it turned. So let's solve this algebraically. 5m is less than or equal to 10. Again, this means multiply. I need to isolate m. What is the inverse operation of multiplication? Division. Division. This cancels out. M is less than or equal to 2. Let's go back to our graph and see if this is so. Are all these less than 2 and equal to 2? Yes, it is. So it's equal to, so we draw a closed dot. Less than 2, least to greatest. Oh, all these. And that is our graph. So let's practice some now. Solve each inequality represents a solution on a number line. So a plus 4 is less than 10. So what numbers of a, if you plug it in, they will all have to, and you add 4 to it, it's all going to be less than 10. So I need to isolate the variable a. So I do the inverse operation of plus 4. So it's minus 4. Minus 4. This cancels out. A is less than 6. So 6, 7, 8, 5, and 4. So it's less, least to greatest, less than 6. So I know it's going to be this side. But does it equal 6? No. So open dot. So let's see if this works. If I plug in a 4 here, 4 plus 4 is 8. That's less than 10. Check mark. It works. Let's do another example. G minus 11 is greater than 2. Let's isolate the variable g. What's the inverse operation of minus 11? Plus 11. Plus 11. This cancels out. G is greater than 13. Let's graph this now. It's greater, least greater than 13. So it has to be all of these numbers that are greater than 13. But does it equal 13? No. So it has an open dot. Let's check if this works. Let's plug it in. 15 minus 11 is 4. Is that greater than 2? It works. Check mark. Let's look at our third example. 3t is less than or equal to 15. I need to isolate the variable t. So what's the inverse operation of multiply 3? Divide 3. Divide 3. This cancels. T is less than or equal to 5. So let's graph it. It least to greatest has to be less than 5. So all of these equal to 5. So it can be part of 5. So we close dot. So let's see if this is work. Let's plug in some number. 3. What's 3 threes? 9. Is that less than 5? Check mark. It works. F is divided by 5 is greater than equal to 8. So what is the inverse of divide 5? It is multiply 5. This cancels. So F is greater than equal to 40. So let's graph this. This is 40, 41, 42. This is 39. This is 38. It has to be least to greatest, greater than 40. All these are greater than 40. Equal to 42. Close dot. And let's check if this works. I want to put in a 45 here because it has to be greater. Or let's do 50. Is 50 divided by 5 is 10? Is that greater than 8? Yes, it does. Check mark. And let's do our last example. Negative 5 is greater than x plus 3. I need to isolate this variable x. What is the inverse of plus 3? Minus 3. Minus 3. Does cancel? Ooh, you have negative 5 minus 3. That's negative 8. Remember, you do add opposite. Add the opposite. So it's negative 8. So this is negative 8, negative 7, negative 6, negative 9, negative 10. So negative 8 is bigger than all of these x's. So negative 8 is bigger than what numbers would be bigger than like negative 7 and negative 6 or negative 9 and negative 10? Negative 9 and negative 10. and all these really tiny numbers. So negative 8 is greater than these. So, but does it include negative 8? No, open dot. So that's it. So what we just did is we were given an inequality. We solved it just like an equation, and then we graphed it. So that's how you solve inequality. In the next lesson, we're going to be working about what happens if you multiply divide by a negative number. It will flip the direction of the inequality.